You're welcome to FUNNYMATH page. This is episode 16 of the likely BECE math questions for 2026 and beyond. So if today is the first time watching my video, I'll urge you to go through the previous episodes, and they're going to be helpful. They're going to help you a lot. Now let's answer the questions that we have here. Now let's get our first question. That is going to be question 1A. And the question is saying that there are 3 green balls and 2 red balls in a box. A ball is taken, not replaced. Then a second ball is taken. You are to use probability tree diagram to illustrate this selection. And after that, we find this one. What is the probability of taking a green ball followed by a red ball? Work out the probability of taking the same color and the probability of taking different colors. That's not the same color. Then we come to the next set of questions. So now let's begin with the first one. The key word is that after taking the first one, we don't replace it. So this is selection without replacement. In fact, sometimes you do the selection and then you put back, the ball in a box or in a container. But for this particular one, we are not going to replace that. So this is selection without replacement. So you have to know the difference between selection with replacement and selection without replacement, because the keywords are very, very important in the drawing and also in answering these questions. So now let's continue. So that's going to be question 1A. So this is how we are going to draw the tree diagram for the selection. So first of all, you have to get the total number of balls, and as read in the question, we have 3 green balls and 2 red balls. So the total number of balls is going to be 5 here. That's going to be 3 plus 2, which is 5. Now this is how you're going to draw the tree diagram. So this is going to be our first branch, and we have our next branches here. So this is what you have to know. What you have to know is that the first branch that you see here, this is for the first selection. This is first selection. Also, this and that is going to be the second selection. So you have the second selection here. So this one that we were making 2 selections, it means it should end at this point. If it was to be 3 selections, then we would have to continue from here, and that's going to be something like this. So see how that one going to be. Since we are talking about double selection here, we have to end at this point. We didn't take an item or a ball twice here. It was just twice, the first selection and the second one. So we can't continue from this. So you should know that we have to end here. So now that we have our first selection and our second selection, the next thing is to get our various probabilities. So let me get them right here. Let me clear this stuff from here. So what you have to know is that anytime you draw the branches, each line should go for one item. So in this case, we have green, red, green, red, green, red. So now we have 3 green. So the probability of taking a green ball, at first or for the first time is going to be 3 on 5. So we have 3 on 5 here, and now the probability of getting a red ball is going to be 2 on 5. So that is what you have to know for the first selection. So if you pick a green ball from the box, you're going to get 3 out of 5, and a red ball is going to be 2 out of 5. Now you should know that when a ball is taken, it is not replaced. So this is selection without replacement or replacing. In this context, we call it dependent event, because so when you take a green ball from the box, the total number of items will be reduced by 1, and that will affect the probability of the next ball that you take. So this is a dependent event. Now let's continue. You see, this is the main branch, the first one, and this branch is for green, even though we have a sub branch for this green, which is this and that. We have red as part of the first branch here, but what you have to know is that this lane or this path is actually for green balls. You get what I'm talking about very soon. And this lane or this path is actually for red balls. So when you come to this path, which is the green balls, the red balls, they are going to be silent here. And when you come to the red lane or red path, the green balls are going to be silent here. This is what I want to see. So now let's see something. After making your first selection, which is green, that was 3 on 5. The second selection, being another green, is going to be 2 out of 4. I hope you have seen the reason why we have 2 out of 4 for the second selection for green, because the number of green balls, it has reduced by 1, and it will also affect the total number of balls in the box. So that's why we have 4 here. Since my attention is on the green balls, it means the red ball is going to be silent in such a way that, the number of red balls in the box will not be altered. It will not be changed. It's still going to be 2. I hope you understand what I'm talking about. So in this case, we're going to get 2, out of 4 here, because the red balls, they are 2. And at the second, selection, the total number of balls were 4. So that's going to be 2 out of 4 for the red. So that's why I'm saying that when you are actually talking about the green balls, the red balls will be silent because you've not altered the red balls. They are still intact. I hope you've gotten the concepts. Now let's come to the next one. So when you come here to, this is for, the red balls. So assuming you take a red ball first, that's going to be 2 out of 5. The total number of red balls is 2. So we have 2 out of 5 in this one. Now, what if the second ball is still red? So that's going to be 1 out of 4. I hope you get that. The reason is that there are, 2 red balls in the box. Now you took 1, you didn't replace. That means the number of red balls left for the second selection is going to be 1. And the total number of balls in the box will be reduced by 1, which is going to be 4. I hope you understand that. Now at this point, the number of, green balls will still be 3 out of 4 here. So you see, this path is actually for red. So the green is going to be silent in such a way that when you select a red ball, then it means a green ball is not altered or it is not changed. What will change is the total number of balls in a box. I hope you understand what I'm talking about here. You see, what you have to know is that each path or each lane has a specific color that we are talking about. So you take the first lane here, which is the green, we are actually centered on the green. So the red will not be altered. When you come and take the red one, we are actually centered on the red, and the green will not be altered. That is what I want you to understand. Now, after getting this done, we are actually done with the tree diagram. But let's make some deductions here. You have to see that, in a second selection, all the denominators are 4, 4, 4, 4. Have you seen that? You have 4, 4, 4, 4. It should be the same. That is what you have to know. Another deduction that we can make from this is this. Now, let's take this one, this branch. You have seen a 2 on 4, and this one too is 2 on 4. 2 on 4 plus 2 on 4 will give you 1. So this one is complete. Always, the sum should give you 1. The sum of the probabilities should give you 1. So here we have 1. This is intact. Let's come to this one too. We have 3 on 4 and out of 1 on 4. So 3 on 4 plus 1 on 4, that one too we are going to get 4 on 4, which is equal to 1. So this one too is intact. Have you seen the deduction that I'm making? Now, we come to the first one too. This one was 3 on 5 and this is 2 on 5. 3 on 5 plus 2 on 5 is also going to be 1. So at any point in time, the total of the probabilities will give you 1. That should tell you that you are on the right path. So that means everything is correct here. Now let's move on to the next question. That is II. That is 1A II. And this is the question. What is the probability of taking a green ball followed by a red ball? They have been specific. The probability of getting, a green ball and then a red ball. That is what they are saying. This is how we can interpret this selection. So they want the probability of J and probability of R. That's the interpretation of what I've just written here. P of J R. That means a green ball first, followed by a red ball. Now, after getting your interpretation like this, what you have to know is this. In probability, the word and, this one, and, means multiplication. That is something that you have to know. And means multiplication. And the word or means addition. So this is multiplication or is addition. So we come to the or later. Now let's make use of the and. Please take note of that. The and in probability means multiplication. So the probability of, green followed by the probability of red is going to be this one times this. So let's move on. If we select a green ball at first, what are we going to get? The probability is 3 on 5. So that's going to be 3 on 5 and means times. So we are done with this one. We move on to the next one, and that's going to be the probability of red. Remember that after selecting the green ball, we didn't replace that. It was taken out, not replaced, as said in the question. So that means that the total number of balls will be affected in the second selection. So that's going to be 4. And the probability of red is going to be 2. The number of red balls is going to be 2. So we have 2 out of 4. I hope you are not confused here. So this is the probability of getting a green ball for the first time. In the second selection, since we didn't replace the green ball in the box, it means the total number of balls will be limited, or it will be reduced by 4. By 1. So we get 4. But the number of red balls, they are still intact. So we have 2 out of 4. So this is what we have. And we know we can simplify this one. Because 2 here, 1, 2 goes into 4, 2. So you're going to get, 3 on 5 times 1 on 2. And that will easily give us, 3 on 10. Because 5 times 2 will give us 10. So that's the probability of getting a green ball followed by a red ball. Let's get our next question. That's going to be question 1A, I. And this is the question. Work out the probability of taking the same color. We have a whole lot of stuff to do here. We want the probability of taking the same color. So now these are the possible, outcomes for the same color. We can get green in the first selection and green in the second selection. That's going to be possible. So we're going to get something like this. The probability of getting a green and then another green. Or the probability of getting a red and another red. So it's going to be like this. Probability of green and green, or probability of, red and another what? Red. So these are the possible outcomes that we can get. Now, I just told you that in probability, the word or means addition. And also the word and means multiplication. So we are going to combine these two keywords here to do our calculation. Now, the first one is probability of a green ball and another green ball. So this one means that probability of getting a green ball and probability of getting another green ball. Or that's going to be plus probability of getting a red ball and probability of getting another red ball. I hope you've seen the interpretation. I just want to make it this way so that you understand the concept very well. So now let's continue. Probability of getting a green ball in the first selection is going to be 3 out of 5. So probability of getting a green ball in the first selection, that is here. That's going to be 3 out of 5. This one. So we have 3 out of 5. And means multiplication. And probability of getting another green in the second selection, that's going to be 2 out of 4. We have it here. So we have 2 out of 4 here. So that's going to be for the green, part. So we come to the red part. Don't forget about the sign, or that is plus. We come to the first, the red part. So the probability of getting a red ball in the first selection, that's going to be 2 out of 5. So you have 2 out of 5 here. And meaning times probability of getting a red ball in the second selection, that's going to be 1 out of 4. So you have 1 out of 4 here. So that is it. So from this point, I know you can, simplify. From this point, becomes, a mere multiplication, simplification of fractions. You can, simplify this one. So now let's move on. We can even multiply cancel this one out. 2 here, 1, 2 here, 2. So after that, we're going to get 1 times 1, 1 times 3, that will give us 3 here. And 5 times 2 will give us 10. Now plus, we cannot simplify this one, so we just have to multiply. 2 by 1 is going to be 2. And then 5 times 4 is going to be 20. So what do? We are adding these two fractions. So we just have to find the LCM. So the LCM for, 10 and 20, that's going to be 20. So let me just work that one here. So the LCM is 20. 10 goes into 20, 2 times. 2 times 3 is going to be, 6. 20 goes into 20 1 times. 1 times 2 is going to be 2. So you're going to get 6 plus 2, which is 8 on 20, which we can simplify. 4 goes into 8 2 times. It goes into 20. We have, 5 times. So the final answer is going to be 2 out of 5. So that's the probability of getting, the same color. Find the probability of taking different colors, meaning not the same color. That's another interesting question. Now, we have 2 ways to get the same answer. I'm going to use the first method, which is very, very easy to use. And we talk about the second method. When the probability of different colors. So let me work that one here. That's going to be question 1A IV. So we have probability of different colors. So let me get that one here. Different colors. So let's see how we're going to do that. I mean, this is a simple way to get the answer. We just saw in a previous question, I mean, the question 1A that the probability of getting, the same color is 2 on 5. I mean, that is here. We know that the total probability is always going to be 1. That is what you have to know. Total probability is always going to be 1. So if the probability of getting the same color is 2 out of 5, then what will be the probability of getting, a different color or different colors? That means we can just subtract 2 out of 5 from 1, and that will give us the final answer. So that's going to be, 1 minus 2 out of 5. Now, we can just subtract this one. So this is out of 1. So the LCM is going to be 5. We have 5 here. 1 goes into 5, 5 times 1. That's going to be 5 minus 5 goes into 5 one time times 2 is going to be, 2. So we have 3 on 5. So that's the probability of getting, different colors. I mean, that's an easy way to get it. Once we know the probability of same colors, we can go ahead and find the probability of different colors by subtracting this one from 1. And that is what we have done here. Now, another way to think of this is this. I mean, that's a very long approach, but I'm going to use that one too. And we have to get the same answer, which is 3 on 5. That's what we're going to do. Okay, so let me use an alternative method to work this question. So that's going to be, the same question. I'm just trying to use a different method. So let's make this deduction from the tree diagram here. We want the probability of getting different colors or taking different colors. So this will be, the possible outcome that we can make. We can get green in the first selection, red in the second selection. I mean, we can get these selections, or red in the first selection, green in the second selection. So these are the possible outcomes. So probability of, so that's going to be question 1A, Ivan. Probability of, different colors. So that's going to be probability of getting a green ball first, and then followed by a red ball, or probability of a red ball followed by a green ball. So these are the possible outcomes that we can make from this, tree diagram. Now let's make our substitutions, but you have to understand that OR means addition, AND means multiplication. So this probability can be expressed as this: probability of a green ball and probability of a red ball. So that means we're going to multiply. So we have probability of a green ball in the first selection is going to be 3 on 5. So we have, 3 on 5 here, times the probability of a red ball in the second selection. I mean, that's going to be 2 on 4. So you have 2 on 4. Now, all means plus. So we have plus here. Let's come to this one. Probability of getting a red ball in the first selection. I mean, that's going to be 2 on 5, this one. So you have 2 on 5 times green ball in the second selection. I mean, that is here. You have 3 on 4. So you have 3 on 4. Remember, we are supposed to get 3 on 5 as our final answer. So let's simplify these guys. So, 2 here, 1, 2 goes into 4, 2. So we have 3 times 1, which is 3, and 5 times 2 is going to be 10. Now, plus, come to this one, we just have to multiply because we can simplify. So 2 times 3 is going to be, 6. 5 times 4 is going to be, 20. So we can just add them by finding the LCM. So now we have, 20 being the LCM. 10 goes into 20, 2 times 3, that's going to be 6. Plus 20 goes into 20, 1 time, times 6 is going to be 6. So we have, 12 on 20. So we can simplify this one. 4. 4 goes into 12, 3 times. It goes into 20. We have 5. So you see we are getting 3 out of 5. And the answers are the same. So we can use this approach or this one, and we have to arrive at the same answer. Now let's move on to the next question. We have to simplify this expression. I mean, these fractions. So let's get that one down here. Let me clear this stuff. So let's get our next question. That's going to be question 1B. Another simple question. You see, when you meet these questions in examination, you see, questions like this, they don't involve any, critical thinking abilities. You just have to, simplify them. So these questions are bonuses that will help you get a better grade in your examination. So don't joke with questions like this. They are very, very simple. So now this expression, we have, 2 on 15 plus 2 on 5, that's in this bracket. And this bracket contains 9 on 10 times 4 on 3 plus the last one is going to be 1 on 5 divided by 1 on 4. So that's the expression. I mean, it's a long one, but the approach is very, very simple. So now we have 3 brackets here. So we are going to simplify the content of each bracket. And after that, we add them. I mean, according to the, the operations here. So let me simplify this, bracket. Now, in this bracket, we have 2 on 15 plus 2 on 5. What do we do to simplify these two? If we have to find the LCM, and the LCM is going to be what? So this is going to be the LCM, 15 and 5. The LCM is going to be 15. So let me just get that one here. So we have 15 as the LCM. 15 goes into 15 one time, times 2 is going to be 2. So 5 goes into 15 3 times, times 2, that's going to be 6. So we come to the next, bracket. Now in the next bracket, we have, 9 on 10 multiplying 4 on 3. This is not addition, so you don't have to find any LCM. We can just multiply the numerators and also the denominators separately. But even before we do that, we can do some simplification. I mean, that is one reason that, why I like multiplying fractions. Because you don't have to find any LCM. You can also do cross cancellation. When I say cross cancellation, something like this. Or diagonal cancellation. You can also do vertical cancellation. So in this case, I can do diagonal cancellation or cross cancellation. So let me do that. So I can say that 3 goes here 1. It goes into 9 3 times. And also with a 4 and a 10, we can use 2 to simplify. Even though 4 cannot go into 10. So 2 goes into, 4 2 times. And 2 goes into 10 5 times. That's a simple way to, get the answer. So let me even write what I have first so that to make our work nicer. So we have 3 on 5 times, 2 on 1. So let's move on to the last bracket. Now in the last bracket, we have, 1 on 5 divided by 1 on 4. So for division, we have to change the division sign to multiplication. So we're going to get 1 on 5 times, after changing the division sign to multiplication, we have to find the reciprocal of this one, the next fraction. So that's going to be 4 on 1. So this is what we have. So at this point, we can, simplify further the content of the brackets. So now 2 plus 6, that's going to be, 8. So we have 8 on 15 plus this one, 2, we have 3 times 2, that's going to be 6. 5 times 1 is going to be 5 plus 1 times 4 is going to be 4 and 5 times 1 is going to be 5. So this is what we have. So at this point, we are adding these 3 fractions. And what do? We have to find the LCM. So the LCM for 15 and 5. So that's going to be 15. That's obvious. So the LCM is 15. So now 15 goes into 15 one time. 1 times 8 is going to be 8. And 5 goes into 15 3 times. 3 times 6, that's going to be 18. 5 goes into 15, 3 times 4, that's going to be 12. So you have to add this stuff. So you have 38. You have 38 out of 15. We cannot simplify this one, so we can just write it as 2 whole number 8 out of 15. Because 2 times 15 is going to be 30 plus 8, 38. So that is how we can, simplify this expression. Let's get our next question. So let's get the last question. That's going to be question 1C. The volume V, that's the amount of water in a tank, is proportional to the square root of C, where C, the rate at which water is kept in the tank, and K, the constant of proportionality. We have to find the value of K if V is equal to 84, and C is equal to 49. We have to use the value of K in I to find the value of C when V is equal to 96. So first of all, let me get the first one here. So that's going to be question 1C, I. So we are saying that the volume V, so that's the volume V, it is proportional to the square root of C. So that's going to be this. This is the symbol for proportionality. So V is proportional to the square root of C. So this is the square root of C. So this is what we have here. Now, we have to change this, symbol for proportionality to equal sign. So we are going to get V equal to, and the moment you change this one to equal sign, we have to introduce the constant here. K, which is the constant of proportionality. So that's going to be K multiplying the root of C. So this is how we can get, our relation. Now, we have to find the value of k if v is equal to 84 and c equal to 49. So if v is equal to 84 and c is equal to 49, how do we find the value of k? So let's do the substitutions here. In place of v, I'm going to write 84. So we have 84 equal to k, that is what we are looking for, times the root of, c, and c is 49. So this is what we have. So we are going to get 84 equal to k multiplying the root of 49 is going to be 7. The reason is that 49 is a perfect square. So 7 times 7 will give you 49. So the root of this is going to be 7. So now at this point, we want k, so we just have to divide here by, 7. So we have divided by 7 here, here too by 7. So 7 will just cancel this 7. 7 goes into SF1, it goes into 84 12 times. So this implies that k is equal to, 12. So that's the constant of proportionality. Now let's get the last question here. 1CII. So you have 1CII. Always you have to write the question number. So we have to use the value of k in that is 12, to find the value of c when v is equal to 96. Remember, we are using this, relation. And the relation is v equal to k multiplying the root of c. Now we know that, k is 12. And now v is equal to 96. So in place of v, I'm going to put 96 there. So that's what you have to know. But I want to write this down. So, but v is equal to 96 and, k is equal to 12. So this implies that v, which is 96, is equal to, k, that is 12, times the root of c. Remember, you want to find the value of c. So what do we do? At this point, we can divide here by, 12, the whole of here 2 by 12. So this 12 will just cancel this 12. 12 goes into SF1, it goes into 96, 8 times. So we have 8 equal to the root of c. We want c, but not the root of c. So what do we do? So you have to square both sides. So that's going to be, 8 squared equal to the root of c squared. So that this one will just cancel this one. So c is equal to, the square root of 8, and that's going to be 64. So that is 8 times 8. So you have 64. So that is how we can find the value of c when k is 12 and v is equal to 96. Thank you for watching.